Hi everyone. In this example I want to illustrate some basic principles of DC circuits. So in this example we have a 12 volt power supply. There's the low potential terminal, there's the high potential terminal. That is connected with a zero resistance wire to a 4 ohm resistor. That in turn is connected by another zero resistance wire to the low potential terminal of the power supply. So in this problem we want to do the following. First we want to find the direction of the current. Then we want to find the voltage drop across this 4 ohm resistor in the direction of the current. We want to find the value of the current itself. We want to find the power delivered by this power supply and dissipated by this resistor. Okay, let's go. To find the direction of the current, first we just identify the high potential terminal of the power supply. The current will flow from the high potential toward the low potential through the circuit, so the current is going to flow this way. To find the voltage drop across the resistor, we can use the loop rule, which says that the total change in potential around the circuit will be 0. So if we have a 12 volt gain across this battery, and that we do because we're going from the low potential terminal to the high potential terminal, so a 12 volt gain across the power supply, we must have a 12 volt drop across this resistor because there's nothing else over which we could have a change in potential. If we want to be really clear about where the potential is higher, we'd write V sub C minus V sub D is equal to 12 volts, and that will indicate that we know that the potential is higher at C than D, and that the current is flowing from high potential to low potential. Of course, usually we just write this as delta V. It's usually very sloppy. Delta V sub R, meaning delta V, the change in potential across the resistor, is 12 volts. That's assumed always for a resistor to be a voltage drop. Current always flows from high potential to low potential. Now there's another way to reason this that's essentially equivalent to the loop rule. This has no resistance in it, so B and C are at the same potential. And there's no resistance here, so A and D are at the same potential. So the change in potential from B to A must be the same as the change in potential from C to D. From A to B we have a gain of 12 volts in potential, so therefore from B back to A we would have a drop of 12 volts in potential. So from C to D we must have a drop in 12 volts of potential, and that is indeed the 12 volt voltage drop across the resistor. To get the current, we can apply Ohm's law to the resistor. Now I have to emphasize here that anytime you use Ohm's law, all the elements of Ohm's law have to be referring to the same thing in the circuit. So for example, we're going to apply this to our 4 ohm resistor. So this will be the voltage drop across the 4 ohm resistor. This will be the current passing through the 4 ohm resistor. This will be the resistance of the 4 ohm resistor. Anytime you use this law, you need to make sure that all the terms in the equation are applying to the same circuit element. Okay, so applying this to the resistor, we rearrange to solve for the current. The current through the resistor will be the voltage drop across the resistor divided by the resistance. So 12 volts divided by 4 ohms gives us 3 amps. Note, we got a pitfall with our units here. We have a V representing volts, and here we have a V representing potential. So you need to be careful not to confuse your potential symbol with your units of volts. Just a little pitfall there. Okay, let's find the power delivered by the power supply and also the power dissipated by the resistor. Now, we've got the same current passing through this entire circuit because it's all in series. So there's no splitting at any junction, so the junction rule says at any point in this circuit, current in equals current out. So we got 3 amps leaving this terminal of the power supply, going here, passing through, going through, passing back through the power supply. So, same current everywhere. We have the same voltage gain across the power supply as the voltage drop across the battery, across the resistor. So in each case, for both the power supply and the resistor, we have the same current and we have the same value for delta V. However, the interpretation is going to be slightly different. Since we have a voltage gain across the battery, or across the power supply, we're having power delivered by this power supply when we use the I delta V form. We have a voltage drop across the resistor. Power is being dissipated. So in both cases, we have 3 amps times 12 volts, which gives us 36 watts. And again, that's 36 watts delivered by the power supply and 36 watts dissipated by the resistor. So the total power delivered is equal to the total power dissipated in this simple DC circuit, and that's the way it should be. All right, thanks for watching.